Hey, my name is Austin Gill, and I am a web developer and educator from Portland, Oregon. Let's get to this talk. It's called Full Spectrum File Uploads. It's going to cover all of the things that I think you need to consider when you allow file uploads in your applications. So the first thing, or the place that I like to start when I talk about web development in general, is the fundamentals. And when we're talking about sending files, we're talking about sending HTTP requests. So HTTP is the language of the internet. It's the protocol that computers use to communicate back and forth over the internet. And it kind of looks like this. We have basically, you can think of it as sort of like a text message that is structured a certain way. So we have up top, the method, the path, the HTTP version, and optionally we may have headers and the body. But the good thing is that we don't actually have to worry about all of those fine details because we have tools available called browsers. And browsers are essentially HTTP clients. They will make HTTP requests on our behalf. They will take HTTP responses and turn them into websites or web assets, and they provide us with some nice APIs and tools to send files such as HTML and JavaScript. So we'll start by looking at sending files with HTML. What does it take? Well, we have to instruct the browser to construct an HTTP request. So we can do that with a form tag and a button. And then it's not good enough to just use the form. We have to, by default, the browser will send a GET request, and we need the browser to send a POST request, which is going to send data. Now we need to access the data that we actually want to send. Unfortunately, or kind of fortunately, browsers or web developers don't have access to the file system on the user's computer. There's a little bit of an exception there, but for the most part, we can't just have arbitrary access to the file system. And that's important. That's a good security feature. But that means that if we want to send files, we need to provide an input with the type of file so that users can select which files they want to upload. And anytime that we add an input to a form, it's important to account for accessibility so that every user, no matter what their capabilities, can use this website. So in our case, we'll add a label tag with the for attribute and attach that to the input with the ID. Then we also want to make sure that we're actually going to be sending the file contents. There's two things we have to do here. We have to set the content type of the HTTP request to multi-part form data, and we can do that with the enc_type attribute on the form element. And we want to make sure that the receiving computer has access to that file, and we can do that by adding a name attribute to the input. In this case, I'm calling mine file. So this is all that it takes to properly and responsibly send a file from one website to another using HTML. When we expect the network tab for that request, when this form is submitted, we will see something that looks like this. We've got the HTTP method and path and version. We've got the content type of multi-part form data, which is important. We also see the boundary here, and this boundary is just a bunch of numbers or characters that sort of separate. They tell the HTTP request how to separate where one input starts and one or form field ends. So we can see there's a couple of boundaries here, and inside of them, because we have one field in our form, we can see the contents of that file input. So the name of the file, the content type, we can see the contents of the file, who's a good boy, because the file was called Nugget, which is my dog. We've successfully constructed our HTTP request using HTML. We are sending files. So users can select files from their computer, browsers will send the file, but when we use forms to submit, or when we submit forms with HTML, the browser is going to reload the page every time. And that's kind of not a great user experience. It's not what users expect these days. So that's where we introduce JavaScript to improve the user experience. With JavaScript, submitting a form is very similar, but a little bit different. We still need access to the file system. We still need to construct the HTTP request. We still need to set the method to post, and we still need to put the file contents in the body of the request. And the bare minimum that we need to do all of that might look something like this. We don't need an entire form. We can do it with just an input so the user can select the file, and then we can use JavaScript to do all the rest of the work. I don't recommend doing things this way. Instead, what I recommend is looking at that HTML form that we had before and adding an onSubmit event handler to it. And that event handler might look something like this. It will use some JavaScript to submit the form with JavaScript and then prevent the default behavior. That's going to stop the browser from the reload behavior that we wanted to avoid. And we can, do some business logic to do something with the response. Now, what that submit form with JS function looks like, it's going to be a little bit involved. So this is what it might look like. It's going to be a function that accepts a form DOM node. And once we have the DOM node, we can take a lot of the information that we need from that HTML. So we can grab the URL where the form is going to be submitted. This is going to default to the current page if it's not defined. We can grab all of the information from the inputs of the form using the form data constructor. We can put together an object that we will use for the fetch request that we're going to send eventually. If the form doesn't have a method provided, it will default to the get method. And next we can do some logic. If we know that this is going to be a post method, we have some work that we need to do. So first we want to check if the request type or if the enc type is multi-part form data, in which case we want to make sure that the content type is set to multi-part form data. Fortunately, just by setting the body of the request to a form data object, the browser will by default set the content type to multi-part form data. However, we don't always want to do that because not always is a form going to be multi-part form data. So if it's not explicitly set, what we can do is set the body of the request, because it's a post method, set the body of the request to a URL search params object, which we can build from the form data object. Now, when we do this, the browser will by default set the content type of the request to application xwww form URL encoded, which is, it imitates the way that HTML would have worked to send the request. So now by doing these two approaches, we're essentially recreating how an HTML form would submit. Now, in the event that we're not sending a post request, we can go ahead and append the URL search parameters object to the URL of the form, and that's going to add the query string parameters to the form submission, which is how a default GET request would work. And lastly, we can instantiate the fetch request and return the promise. Now, why would we do it this way? Well, first, this supports progressive enhancement, which means it's going to work with or without JavaScript. If JavaScript is slow to load or fails to download or there's a spotty connection or whatever, this is still going to work because it will fall back to the HTML, which we had seen before. This also maintains existing browser features, which is really good for users that know what they want to do or are familiar filling out forms, and it maintains accessibility because, again, we built the form with HTML before and we made it accessible the first time. This also has the benefit of being simple. By constructing a function like this that can work with any form, we can reuse it across our application without having custom form submitting logic in several places. This also means that the JavaScript is going to take its instructions from the HTML. So this is a very declarative approach where all of the customization happens on each individual form. And this makes it very resilient and maintainable for your project. So we've improved the user experience with JavaScript. Users don't have to wait for the page to refresh. We are still supporting progressive enhancement in case JavaScript fails. But so far we've only covered the client side of things, and we aren't actually talking about what happens to the file on the other side of the network request. So we're going to look at what it takes to receive files in Node.js. Now, Node is an event-driven architecture. So when an HTTP request comes in, we have access to that request and the on method. And if we can tap into events on that request, such as when data is received. And let's say, for example, we wanted to log the data as it comes in. If we do that, we're going to see a number of these logs to the console that look like this. So these buffers with this weird random numbers and letters. And a buffer, you don't necessarily need to know distinctly what it is, but JavaScript essentially doesn't have access to bytecode necessarily or to work with bytecode directly. So we have these concept of buffers which allow us to have a space in memory to work with bytecode without necessarily processing it directly. Hopefully that's clear. Again, if you want to look into it more, you can read up on it, but you don't need to understand it very intimately to continue. Instead, what we can do is take that function that we wrote and we can modify the body of it. So let's say we have that function that works with the request as it's coming in, and we want to return a promise because we prefer promise architecture to callbacks. Now, in that promise, we can construct an array to hold the chunks as they come in, and when a chunk of data comes in, we can push it to that array. Then when the request finishes, meaning all of the data has been received, we can take that array of buffers and concatenate them and turn them into a string and resolve the promise with that payload. And if we do that and we log the resolved value from that function or from that promise, we'll see the actual data that has been sent across on the HTTP request, which is all of the data that we saw before. We have the content type with the multi-part form boundary. We have the contents of the file, and this is great. Couple of problems here. We've made some terrible mistakes. First, we are essentially going to be writing all of the chunks of that file into memory. And if we do that with a large enough file, we will exhaust all of the memory resources from the server, and the server is going to crash. Second, we are dealing with essentially a string of that HTTP request, which means we still have to parse it and do something with it. And these are two big problems that we can avoid by using a streaming library. So streams allow us to take chunks of data and work on them and put them somewhere, like writing them to a file system and then releasing them from memory. So we're not holding on to them. We're processing them as they come in, writing them to a file, and then letting go of that memory so that as more chunks come in or more buffers come in, we can write them to disk. But it doesn't make sense to do that manually, because libraries have existed for a long time in the Node ecosystem that do this for us. So as long as we're working in the Node system and we're dealing with base layer request objects, we can use Formidable, which is a library that I personally prefer, but you can choose whatever. We can pass that request to Formidable and parse it, and Formidable will give us back all of the fields in the request and all of the files, and we can resolve the promise with that information. And when we do that and we log the contents or the resolve value of that promise, what we'll see is an object containing all of the files and fields. In this case, I have a field called file, which represents the file that was sent. And here we see a lot of information about that file, particularly the path to where the file exists, because usually we're not necessarily interested in the file contents as much as we are that the file exists on the disk. So we are successfully saving files to disk. We have access to all the metadata around that file. We are using streams instead of memory, and we're not reinventing the wheel because we're using a tried and true library. But what is going to happen as more and more users are uploading files is we're going to run out of space, which means we're going to need more space. And we have to solve that problem by either upgrading our server or something else. Another concern is what happens if we have a distributed system, meaning users are uploading files, but our application is running in multiple computers. It's going to be hard to track down where those files are being written if they're on different machines. So there's a solution to both of those problems called object storage. Now, object storage is basically a single place, a central place to store all of your files. And this is nice because they're highly available, easily scalable, and often can be 10 times cheaper than the server space. So, for example, if we're talking about the Akamai pricing plans, if you were to spend $5 a month to upgrade your server from like a base level to the next level up, you're going to get about 20 gigabytes more of storage space. If you instead use object storage with that $5 a month, you're going to get 200 or maybe 250 gigabytes more storage. I forget off the top of my head, but it's essentially 10 times more space for the same price. Now, obviously, upgrading a server is not only about disk space. There's cases where you need to upgrade your server for adding CPUs or adding more RAM. In that case, it makes sense. But just for the case of file storage or server space, it doesn't make sense to upgrade your server. It makes way more sense to use object storage. Now, if you're going to use an object storage provider, I would recommend finding one that is S3 compatible. Most of them are, but definitely be sure to check on that. Why does that matter? Because S3 stands for Simple Storage Service. It was a product that was originally designed at AWS. And along with the product, they actually ended up designing a protocol for using object storage. So the nice thing about having an S3 compatible object storage is you can tap into existing resources such as libraries that are maintained by AWS, but can actually work across different providers. So how does object storage work, or what is the workflow? You basically have two different ways to take your files and upload them to this object storage bucket. You can use signed URLs, or you can use what I call a stream through proxy. Signed URLs look like this. The front end or the client is going to make a request that goes to the back end. It's going to ask for a signed URL. The signed URL or the back end is going to make that request to the object storage provider to get the signed URL. And the signed URL is essentially a URL that clients can upload files directly to that is authenticated for a very short amount of time. So the backend is going to grab that URL, send it back to the client, and then the client can upload files directly to the object storage provider. Now, the benefits here are that it moves some of the work off of your server because the files don't have to pass through it. It moves a lot of bandwidth off of your server for the same reason, and it can be a simpler architecture than processing files on your backend. The downsides here are if you need to store a file and keep a record of that in a database, it's a little bit harder to coordinate because the file never passes through your backend. Also, you have less control over what happens to that file or what files get uploaded. Essentially, a client can upload whatever file they want to the object storage provider, and that means you can't do things like check the contents of that file for malware or optimize images that are uploaded or any other sort of processing you want to do on that image before or on that file before it gets uploaded. This could have impacts on how much you pay because users could potentially upload a very large file. Also, importantly, this approach doesn't support progressive enhancement because HTML only supports GET and POST requests, and uploading files to an S3 compatible object storage provider requires a PUT request. So the alternative is to use streaming through Formidable or streaming through your service. So let's say we have that same node server running, we're running Formidable, and instead of having it write to the file system, we want it to write to our S3 compatible object storage provider. We can do that by setting a custom option called the file write stream handler, which accepts a custom function and is going to give you access to information on the file. So before we get into it, this part gets a little bit into the weeds. So let's just talk about what we need to do for this stream processor. We basically want, what Formidable wants is to have access to a stream that it can write data to. So we need a readable stream to be returned from this function. The S3 upload wants a stream that it can read chunks from. So we need a readable stream. We also need to remember or keep track of the file's location where it gets stored. And we need to keep track of all of the pending upload requests because they can take a while, and keep in mind you might support multiple file uploads at the same time. So there might be multiple request processing simultaneously. So here's what a solution might look like. We have this custom function for the file write stream handler. Inside of it, we instantiate the upload requests using our S3 compatible libraries, and we need to keep track of what these streams are. Remember that the upload needs to be a readable stream. Whatever is returned from this function needs to be a writable stream because Formidable is essentially going to write to the stream that is returned, which also needs to be read from when we upload the files. So what we can do, or the solution for that, is to use a pass-through stream. It's essentially a stream that can be written to and read from. And you can pull this in from the stream node module. Now, once our upload is ready to go, we can kick off the request, but we also want to make sure that when it resolves, we do something with the location. In this case, I'm just adding or appending to the file's metadata the location that I get from the location of the response where the file gets uploaded. And lastly, we want to keep track of all of the upload requests that are happening simultaneously. So I just have an array that pushes the upload to that array, just to track when all of the uploads are complete. Now, when we do that, if we look at the same log that we saw before, a couple things are different. The create file write stream is now going to be the function that we wrote. And we're going to see that we have access to the location, which is the object storage location. In this case, it's a Linode object storage and the bucket where it exists. So now I have access to where that file is going to be in its object storage. There is a major caveat that I need to mention here. Is when you have signed URLs, users are uploading directly to object storage. When you are using a pass-through stream, that file is entering into your server and then exiting out of your server to the object storage provider. This essentially doubles the bandwidth that you are using to process that file. And depending on who your provider is, this could have double the costs associated. So it's worth looking into that. And there's a few other things to consider, but I don't have time to go into them today. If you have questions about caveats or things to consider, feel free to reach out to me. Good news is we are using object storage. We're getting more space for much less cost. All of the files are being stored in one single central place, and we have a separation between the servers and where the files are stored. So we can bring up more servers or less or fewer servers and not worry about what's happening on the files on that server. Downsides, or things that we still need to address, is that object storage, while it's great, when you deploy it, it's sort of like deploying a server. It exists in a single region. You have to tell your service provider which region you want your object storage to exist in. And depending on your audience, and if you have people from around the world coming, this could cause latency issues to those users. So the solution there is to put files as close to the user as possible. And we can do that with this service called a content delivery network, or CDN. Now, fun fact, Akamai was actually the first company that pioneered the idea of CDNs 25 years ago. And it's essentially a globally distributed network of servers that can cache content as close to the user as possible. So instead of being deployed to a single region, it is global. And the way it works is when a user makes an initial request, let's say for an image, the request will pass through the CDN node as close to the user as possible. That request, it will follow through to the origin where that image exists, and then it will pass back through the CDN node, get cached there, and then be sent to the user. So the initial request, the user is still it's going to look a lot like a regular origin server request, but for every subsequent request, for users that are coming from the same region and passing through the same CDN node, they'll actually receive the cached version of that image instead of having to go all the way to the origin server where it's hosted. So this has the effect of making static assets like HTML, CSS, JavaScript, images, fonts, etc. Be delivered a lot faster. As an example, I uploaded a photo of my dog Nugget to a server or an object storage bucket, and I checked how long it would take to serve that image directly to users in Tokyo, Japan. It took about 1.1 seconds. And when I fronted that object storage bucket with a CDN, we can see the effect is pretty great. That same user or the same request coming from Tokyo, Japan for that same image now only took 0.2 seconds, which is substantial. And if you consider the fact that this can actually have compounding impact for render blocking resources, basically how the browser will parse HTML and come across certain resources that have to be downloaded before the HTML can continue parsing, this can have a compounding effect on performance. Other things to consider is that if you're going to introduce CDNs, that's a layer of caching, and caching is really hard to get right. You have to consider how long you want to cache things, what you're going to do in the case that you have to invalidate a cache. Also things like where you're going to host your object storage bucket, or what, if you want to use a subpath versus subdomain and account for cookies and all this and that. And if you are familiar with CDNs, and this is kind of an old story, they have been around for 25 years, I would recommend that you take another look at some of the changes that have happened in the most recent years. We have things like introducing a lot more security features at the CDN or at the edge level. We have tools like automatic media optimization and edge compute. And again, this is across multiple CDN providers, not just Akamai. So now we are delivering files as quickly to the user as possible. We are consuming less bandwidth. We have higher availability, and we have faster responses. But we still haven't addressed kind of the elephant in the room, and that is what happens if we have bad actors that are trying to upload malware. And that's where we have to focus on securing our application. Fortunately, there's organizations like OWASP.org that provide cheat sheets conveniently, like the file upload cheat sheet, for what to do. And so I'm going to walk through all of these steps and show you how we can do this in our Node application. So first, we have file name sanitization. You basically want to prevent super long file names or file names that contain invalid characters that are not allowed in your operating system. Fortunately, Formidable actually does this by default, but if we wanted to, we could provide a custom file name option, which is a function that accepts a file and just has to return whatever we want those file names to be called. Next, we want to limit the size of files that are uploaded because it's going to impact storage costs, bandwidth costs, and potentially performance. So this is going to be very subjective to your application. You basically want to allow the smallest file types that are still within a reasonable expectation for your users. So if you're accepting something like PDFs, you can probably get away with a smaller file size limit. If you're accepting things like images, that's going to be a lot harder. So you'll need something much larger. Formidable by default sets the value to 200 megabytes, but they also provide an option for you to set the max file size to whatever you want. You also have to be aware of where you are storing the files once they get onto your server. If you're going to host them, let's say, on your server, you want to make sure that you're quarantining them away from where your application is running in a folder that has limited permissions. So you don't want the files to be uploaded and be executable in that folder. So Formidable by default uses the operating system's temporary folder, not a great place to store files if you need access to them later on. So you can set the options of the upload directory to wherever you want. Just make sure that the folder that you do set it to exists and doesn't have executable permissions. Next, we want to do some extension validation, basically limiting the types of files that can be uploaded to your system using the extension. So with Formidable, we have the option of providing a filter, which will filter out files before they even get written to the disk. And we can do something like this. We can say, if we had an application that should only deal with images, we want to filter out anything that's not an image. So here's a regex that accepts JPEGs, PNGs, GIFs, AVIFs, whatever, and basically tests the file name, the original file name for that. Now this has a double asterisk because testing a file extension is not really bulletproof, because users can basically very easily change the name of the file and just modify the extension to be something that it's not. So we have content type validation, which basically allows us to check the contents of a file. So we can do this similar to the file extension filter. We can filter files based on their MIME types. So once again, with the filter, we can check. Formidable will give us information about the MIME type. However, this has a double asterisk as well, because in Formidable, the MIME type that they report is pulled directly from the file extension. So once again, the user can rename the file extension. Formidable will tell you a different MIME type, and really the only way to know what the MIME type of a file is by checking the contents of the file. That's the only way to be secure. And that kind of, so this is not entirely bulletproof, but it does bring us to our next point, and that is file content validation. So this is basically where we use some sort of malware scanner and check the actual contents of the file once it's already been uploaded. Now, there's a couple things to be aware of here. The file must already be on your server in order to scan it. You cannot really scan files in flight because you need the whole contents of the file. Scans also take too long for a request response cycle. Users expect responses to come back right away, and especially for large files, it's just too much to wait for the file to upload, wait for it to be scanned, and respond to them. So this introduces what we need is a new architecture for our file uploads. So this is what it might look like, kind of a simplified version. We can take our file uploads, we can store them in some sort of quarantine on the server, or maybe object storage. We can save the file metadata to and the status on whether it has been scanned yet or completed a scan in some sort of database. Then we can, before we actually do the scan, we can respond to the user and let them know that the file has been uploaded, we've received it, but we're still pending, it's in a pending state because it still needs to be scanned. And if your application, if it makes sense for your application, because you have access to the metadata, you can allow users to view the file's metadata, but maybe not download the file because you don't necessarily want to potentially distribute malware to other users. And in the background, you're going to have some process that is scanning any sort of pending file. So reading information from the database, finding all the files that have not been scanned and scanning them. And when it's complete, it'll update the database. So that way, any clean file will be updated, and then you could potentially distribute those files, only the clean ones, to users. And any of the dirty files or any file that is malware, you can, it depends on what you want to do, on how you want to approach the strategy for dealing with malware or users that upload malware. This is what it could potentially look like. We have over here on the left, the user's computer, they send the file to your server. The server is going to put the file somewhere, maybe object storage, and it's going to, at the same time, put an entry for that file in the database. Now, somewhere in the background, there's going to be some job, maybe like a cron job, that is going to read from the database, grab the location of any files that have not yet been scanned. It's going to go to that location and grab that file from it, do some sort of malware scan on it, and it's going to, do something with that malware, whatever your strategy is going to be. Hopefully that sort of helps solidify the concept. One other thing that we can do, notice that that previous version and what I said before is that the malware has to be in your system for you to scan it. But there's one other thing that I want to mention, and this is going to be specifically an Akamai product. And I only say that because I haven't found any other service that offers something like this. And this is scanning or blocking malware at the edge. Akamai has this service called App and API Protector. Any customers that have access to App and API Protector have a bunch of security features that they can enable at the edge before traffic gets into their or onto their server. One of those features is malware protection. And so in Akamai, you can enable malware protection. You can basically set some rules to say any file that is scanned and determined to be malware, we can do things like deny the request from coming in and alert us that there's been malware. So how this looks like is I have a very simple application. I try uploading a file which looks like a good file. It's a text file. And I try to upload it, but this file actually contains malware. And when I check the network request after trying to upload this, it's passing through the Akamai edge, and I get a 403 response, meaning it was forbidden. The request gets blocked. And the really cool thing about this is that it was easy for me to set up. It didn't require any changes to my application. So the logic around that 403 status and basically preventing that request, that was logic I didn't have to deal with. The file is being scanned at the edge before it even gets to my server, and it works really well. And the other nice thing is I don't have to maintain it. If I run my own malware scanner, I have to constantly be updating for any sort of new malwares that needs to be added to that malware scanning database. The downside to scanning files at the edge, of course, is it is limited on the file size because it has to intercept requests on their way to the server. It can't scan the entire file of the entire contents of a large file. So it's still not going to work for everything, but it is nice to have an immediate layer of protection. So we have successfully secured our application. Files are being quarantined. Users are still getting fast responses, and all of the scans are happening in the background. The only downside is this was a lot to cover and you may have missed some things. So if that's the case, the good news is I created a blog and video series. You can go and find it at this URL. And I also should just mention the Akamai products that we do support all of the things that we talked about today. We're going to be the VPS, object storage, CDN, and malware protection. And the reason why it's good to mention those now is because before I go, I want to give you an offer. If you are not an Akamai customer, you can go to linode.com/AustinGuild. That's going to give you $100 in credit if you sign up. And if you enjoyed this talk, I'd appreciate if you hit this link. It's just going to pre-fill out a Twitter thing. You can just tell me whether you liked it. You can tell me whether you hate it. You can tell me how it can be improved. But I want to thank you for listening. And if you would like to connect and keep in touch, here are all of the places you can find me on the internet. Thank you again for your time and attention. It was a pleasure. And I hope that we can catch up online.